Well, we're back with our lesson 14 in the 9x9 Kenken with no operation signs, and I finally got this 7 backward belongs. It should have been there since about lesson 4 or 3, and it's been missing. Fortunately, it hasn't affected our strategy up until now, but it might in this lesson, so I'm glad it's back. We talked about this 18 cage in the last lesson, and it's time to take care of it. It's pretty easy to get some of these out. If we use this as a multiplication problem, then we've already factored 3 out. So if we'd like to, we can use the factors of what's left. 6, if you factor out 3, you've got 6 as a factor left. And if you factor 6, it factors into 1 and 6, or 6 and 1, or 2 and 3, but we can't put a 3 here because this 3 blocks it out. But we could put a 3 here and a 2 here. 2 times 3. We can't have 2 times 3 this way because the 3 blocks it. Now if we were to do this as an addition problem, there are some other numbers we could put in here, because 7 and 8 add to 15, the missing 15 from this 18. Because if we have this 18 and we already have 3 of it here, there can only be 15 left for these two. So 7 and 8 would work. 8 and 7 would work. 9 and 6 would work, except this 9 is blocking a 6 for this cell, 9 for this cell. But we could have the 9 here and the 6 here. So 6 plus 9 plus 3 would work. 7 plus 8 plus 3 would work, etc. You understand. Now that we've added a couple of digits in here, let's try to get rid of some. It should be fairly easy right away. Remember a couple lessons back I was talking about when I saw this 7 and 5 here, this combination, I said, I think I see something. Well, now I'm pretty sure I know what it is. It's this. This 7 looked suspicious. If I have a 7 here in the 2 cage, if one of these is a 7, the only operation I could use to make it work out to be a 2 would be subtraction. I would subtract 5 from 7. And I could get 2. There's no other operation. There's nothing else I could do involving a 7 that would give me a 2. So if I use a 7, I must use a 5. But I can't use them both because one of these in this 315 cage must be a 7. If this isn't a 7, then it's got to be a 5. Those are our only 2 possibilities. And if I'm already using the 7 and 5 here, I cannot use it here. So I can't use that combination of 7 and 5. And since 7 is the only time I can use 7 is if I do that combination, obviously a 7 will be impossible to exist in this cage. Why didn't I erase the 5? Because we know that's the only possibility to use 7, but there's another possibility to get 2 using a 5. If I use 5, I could subtract 3 from it. So this is a possibility. This 5 and this 3 is a possibility. Let's make sure it's a possibility. What I'd like to do is try. We'll see if I really use this 5-3 combination. What I'm going to do is lightly, now I would do this in light pencil normally, I would cross out all the things it couldn't be. So we know this could be a 3 or a 5. And this could be a 3 or a 5. No other possibilities. Well, if that's the case, this cannot be a 5, right? Because one of these is a 5. So let's ditch that 5. And we'll have to ditch that 5. And we'll have to ditch that 5. And of course we have to ditch all the 3's in that column. Well, that's quite a bit. But if we ditch this 3 here, we also must ditch this 8. That won't be a possibility. We're sort of going down a rabbit hole here, but I'm not going to keep doing it for a long time. I think I can see results right away. That's why I tried this. So if that can't be a 3, that can't be an 8. So if the combination 5, 3 is our final combination here, then we'll know 4 and 6 must be the combination here, because there's no other possibility there. So if 4 and 6 are the combination there, we'd have to get rid of all the other 4s and 6s. We'd get rid of that 6, that 6, that 6, and that 4. Well, since before, you notice we've gotten rid of this 5. If we get rid of this 5, that leaves us with a 7, no matter what, in this cell. Well, if we follow through and we use what we did, it turns out this would leave us only a 7 in this cell. This would be a 7, and this would be a 7. So if I did use the combination 5, 3 here, these would both end up being 7s, and that's clearly impossible. So I would go back and erase all those light pencil marks. I can do it a little faster in Photoshop than you can. And I know now that I cannot possibly use a 5 here. So let's ditch the 5. Because 5 is the only possibility, that 5-3 combination. Could I possibly use a 3? Yeah, I still could use a 3 and a 1. This 3 and this 1 to get a 2 here. So I've only eliminated a 5 from here so far. We'll eliminate a lot more in the next lesson, but it's starting to get a little long. So we'll leave it at that for now, and we'll do the rest in lesson 15. See you later.